I was poking around in my shed earlier on, and I suddenly saw a familiar face poking out at me. It's a great big huge thing, and it is a calculator made by Casio of 1967. So I thought, oh well, let's plug it in. And so, well, we plugged it in. To my amazement, it didn't go bang, it didn't catch fire, and it even worked. It takes a bit of time sometimes for the figures to come on, and well, we can see there's some oscillations starting. It's obviously not entirely happy, but to my amazement it works. Earlier on, when I first started to turn it on, probably after 10 years of not starting it on, the digits didn't come on all together, and I turned it off and turned it on, they came. We're still waiting for this one over here. I might do the same. Oh, there it comes. Now, all cancel doesn't seem to stop anything. Sometimes it does, but sometimes one presses the naught and just enters a range of noughts, and that's fine. It's not too happy on subtraction, and these buttons sadly are stick down, so I don't want to press them, but it doesn't seem to be too happy on that. It's a programmable 19 steps, and so I didn't think it worked because it was in the right position. It has a core ferrite bead core memory, and it's got 4 constants. And I think that the numbers might well be automatically put into constant. It does times, but divide seems to give it a problem. Let's do 3 times 2 equals, it's done it. Let's do 26.1. Right, all cancel. Here we are, let's put the, right, 26.1. It's got the decimal point in the wrong place, must have put that in. Times 2 equals 522. Let's see if we can get that decimal point in the right place. Right, so let's try and get a decimal point. 45.9 stuck down. Oh, I wish it hadn't. Might not have stuck terminally. Times 2, good, equals 91.8. Now, if we do something really simple, like 3, cancel. Let's give it the zeros again. 3 times, right, 3 times, yeah, dear, it's not feeling happy. Wonderful oscillations coming here. Right, cancel. Right, the programmable, that's for reading the memory, I think, and that's for writing the memory. Let's put it into neutral. Needs a bit of coaxing this. 3 times 3 equals 9, 81, and so it's obviously put the last number into the constant, and it's squaring it. And when it gets to very large numbers, you can actually see it thinking here. I wonder if it will do that very large number. Maybe it's come out with an answer. Let's do 2 times 2. It might be a sequence that's more familiar to people. Oh dear, it's oscillating again. 2 times, it's timesing the constant. Cancel constant. Right, 2 times 2. Oh, times 2 equals 4. Here we go. 16. 256. 65,536. Here we come to a rather large number. Is that 4,000 million, 200,000, 94? Yes. Well, it seems to cope with quite a few digits, and I love seeing it calculating. and these neon tubes have little elements which light up, and you can see them coming from front to back. It's rather the old-fashioned way of display. I think you see that sometimes on old petrol pumps. So yes, it still multiplies. Dividing and subtraction, I can't press that button. Square root doesn't seem to want to work. But it's absolutely amazing. 1967, so there it is, 2 years old, still, well, essentially working in part, no doubt restorable to be functioning in full. I've just undone the screws from underneath so we can hopefully lift the cover off. Yes, here we are. Now from memory, I think the core memory might be on the back. Right, here we are. So we can lift the top off. Here we've got the keyboards. Sticky keys. A nice wheel to deal with the number of decimal points. Here we've got the individual transistor logic cards, the vacuum tube alphanumeric display units there, and then we've got the cards, and I think these are actually documented on the net. I've seen them somewhere. Now, what's at the back there? I don't know what those are. I know that I've seen the core memory somewhere. I can't remember where it is. Can't see it down there. I wonder if it's at the bottom. There's lots of interconnecting wire at the bottom. Let's have a look. Screwdriver. Here we go. Right. Nice lot of spiders' webs. Nice piece of hardboard at the bottom. No fancy metal. Oh, that's going to defeat me. Bother it. It's why is it one always gets one screw that defeats one bolt that's just too tight? Here we go. There we are. Still can't see the core memory. I know I've seen it somewhere. So here we have the interconnecting wires instead of a motherboard as such. If I find the core memory, I'll take a photograph of it. Having got the lid off, I thought I might just turn it on to look at these displays again. You can see it's happier at turning on, but you can see here the way in which those are constructed with the elements at different levels. Cancel 0. Right. So 1, 2, 3, 4. 7 is an awkward one, I think. 8. Come on, come up. 9. And you can see the way in which 9 seems to be at the back. And then let's do times. And you can see the numbers going from front to back there. It's rather fun to watch. And finally it will come out with the answer. Come on, the telephone's ringing. I need to answer that. And oh, it's come out with the answer. It did eventually. Hope you've enjoyed this tour of a 1967 calculator. Bye.